Let's multiply some square roots together. Now we did come across this property that said if we took the square root of a product, we could split that product into two square roots. So when we had an expression like the square root of 18 and we wanted to simplify it, one of the rules of simplifying was that our radicand, the number under the square root, wasn't allowed to have any perfect square factors. So we looked at 18 as being 9 times 2. Then we split that square root into the product of two separate roots, square root of 9 times the square root of 2. Since the square root of 9 is 3, and the square root of 2 we can't simplify, we rewrote square root of 18 as 3 square root of 2. Then, if we have 3 square root of 18 and we want to simplify that, well, as far as the square root goes, we looked at that as square root of 9 times square root of 2. So 3 square root of 9 times square root of 2. Square root of 9 is 3. Square root of 2 is square root of 2. So we can only multiply together the things that are not under the square root. And then the things that are under the square root, they can be multiplied together. So in this case, we have 3 times 3 outside of the square root. And under the square root, we just have a 2. So 3 square root of 18 can be simplified to 9 square root of 2. For one more example, let's simplify 7 square root of 50. So the square root of 50 would be square root of 25 times 2. Splitting up the square root, we get 7 times the square root of 25 times the square root of 2. The square root of 25 is 5, and the square root of 2 is the square root of 2. So we only multiply together those things that are not under the square root together. So 7 and 5 is 35, and then we have that square root of 2 afterwards. But what about when we're multiplying two square roots together? If we look at the square root of 5 and the square root of 10, we can't find perfect square factors for either of those. For instance, square root of 5 would just be square root of 5. And the square root of 10, well, that's 5 times 2. But if we break it up into its factors and then kind of put parts of it together, we see we have these two square root of 5s. When we multiply those two together, because we can multiply things that are under the square roots together, square root of 5 times the square root of 5 is the square root of 25. Then the square root of 25 is 5, square root of 2 is just square root of 2, and it's simplified. So when we come across the square root of 20 times the square root of 3, you don't want to necessarily put it all together and then try to simplify it. Most of the time, it's easier to just keep breaking this up. For instance, that square root of 20 would be the square root of 4 times the square root of 5. And then we still have that square root of 3 afterwards. I know that the square root of 4 is 2. The square root of 5 can't be simplified, and the square root of 3 can't be simplified. Now we have the two factors that are under square roots. We can multiply those two together. So we'll leave the 2 out in front, and the square root of 5 times the square root of 3 would make the square root of 15. So there is our simplified product. And if we have square root of 12 times the square root of 63, take it in pieces. That's square root of 12. 12 is 4 times 3. For the square root of 63, 63 is 9 times 7. Looking at all of our pieces, the square root of 4 is 2. Square root of 3 we can't simplify. Square root of 9 we can simplify. And the square root of 7 we cannot, so it'll stay square root of 7. When we're putting this all together, we can only multiply together numbers that are both outside of the square root, so 2 times 3 would make 6. And we can multiply together these factors that are both under the square root, that 3, square root of 3 and square root of 7. So 3 times 7 is 21. And that's how you can simplify the product of square roots.